Okay, so now we're doing the problem questions of the network section of the 2023 exam 2. So here it says we've got a network with some distances and landmarks, and I am going to do probably this question A first because I want to practice the Dijkstra's method of finding the shortest path between two vertices, which is what A is asking. So let's have a look here. So doing A here. So with Dijkstra, we want to start at Eden wants to travel from G to M in the shortest way. So that's like a minimum distance. So we can use Dijkstra. So we want to get from G to M. So with Dijkstra's, what you want to do, you have a starting vertex, which is they're saying is G, and you are going to find the quickest way to get to every vertex from G. And so you just look around. So if you look, so it's G to G is 0. If we want to, the quickest way to get to H would be straight out this way. So H is going to have 1.7. Now, the quickest way to K, we could go, but 1.7 plus the 1.1, but that would be 2.8. So the quickest way would be this way. So to get to K is 1.5. Then to get to L, we could go 1.5 plus the 0.9, which is 2.4, or we could have come via N, which I'm going to say the quickest way to get to N from G is 1.8. So 1.8 plus 1.8 is not as quick as 2.4, so I'm going to leave that as 2.4. Now, if we go trying to get to O, if I do 2.4 plus the 1.4, that would be 3.8. And if I went via N, that would be more. So I'm going to put the O is 3.8. Now, if I went to M via O, that would end up being 6.4. So if I just put, I'm just going to put 6.4 there. Now, if I go via, I'm looking up at I. Now, I could go along the top here, which would be 4.9, or I could come along via K, which would make it 2.7. So there's 2.7. So if I try to get to M from I, you can see that was going to be 5.9. So that's smaller than the 6.4. So I'll rub that one out. So now we've got the answer. So that was 5.9 to M from G. But so we'll just leave that there. So hopefully you've done that, because then the next question it asks us, it says Reynolds would like to visit all the landmarks and return to G. Write down the route and the minimum distance the route he would take to get the smallest amount. So because you've done the Dijkstra's, it can help, because this is unfortunately trial by error. And it's just probably, I think so low. It's at the end of the paper, but let's do it anyway. So we'll start off at G. Now we have to go to every vertex. So I'm going to say if we go to G and I take off, and I'm going to go to H, because I now go to H. Now I knew to get out here, we went via K. So probably that's going to be the shortest distance. So if you look at H, the shortest distance to another one is K, so which is the 1.1. So I'll take that one. Now I've got to get out to this J, because it's way out the other end and we have to get to everyone. So I'm trying to look at the shortest way. So I'm at K now, and I look and I say, well, that was the shortest way out to I. Now to get out to J, well, I could go from I could go M and then J, but that would be, 5. Well, I'm just going to take the shortest path. So there I get out to J. Now I'm going to come back. So I haven't been to M, so I'll go to M, and that's 2.1 is shorter than coming out to 3.8, and I have to go to M. So I needed to get to there, and then I'm stuck on this path. So then you get here to O, and now I can say, well, I've got to get to L and back to G. So I'll go out this way, 1.4, then I'll go to N 1.8 and then home. So it's a little bit of trial and error. You might want to redo it and check, that if you went to K and you go out this way, you can't get, if you went out to K first, so I'm saying you go, we still go the same way, but if we go from K, we go back out this way, you sort of, you're stuck going, you find that you're already starting to use bigger paths, so that one, it's not the way to go. So anyway, so we've worked out the quickest path there. So we'll just write it. It just said the path. So we went to G to H to K to I to J to M to O to L to N and back to G. Okay, so I honestly think that we probably need to use the Dijkstra's for the minimum because it will help you, with your trial and error for this one. All right, so then with this next question, it says, Shiloh would like to travel along all roads. So when you want to use all the paths, that's something to do with all the edges. That's going to be a Eulerian something. So it's either going to be a Eulerian circuit, Eulerian circuit or a Eulerian trail. So to complete the journey in the minimum distance, she will travel along 2 roads twice. All right, so it's not going to be a technical true Eulerian because she's going to double over on a road twice, and they're telling us she needs to do that. So if Shiloh will leave the landmark from G and end at a different one. So when they're saying start at G and end at a different one, that means that must be what that she really wanted, that must be a trail. Yeah, because you want to start and finish at a different spot. Now, with a Eulerian trail, if we were to be able to do it, we would only have 2 odd vertices and the rest would be even. And the 2 odd vertices would be where you start and finish. So what we want to see is we probably want to go, so we want to keep G odd. Now, when it says we want to travel along 2 roads twice, it can be similar to those questions where they say, what roads would you add? So we can just pretend like we're going to add a road to 2 sections so we can make it a Eulerian trail. So let's go up here and we're going to have a look. Now, I'm just going to erase this out so that you've got a fresh look at the network, okay? Because we're now talking about this and we want a Eulerian trail, but we know it's not going to be possible. We have to walk along 2 twice. So let's just first, we're going to get the degrees of all, this is where we want to start, and the degrees of all these vertices. So that one's 3, this one's 3, this one's 4, this one's 3, this one's 3, this one's 4, 3, 3, and 4. So if I look at, now, I want to, so when I want to start and finish at an odd one, but we want to make sure we're starting at G. We have to start at G. So G's got to remain odd, okay? So then if I look at all the other odd vertices, so we've got 1, 2, 3, 4, and 5. I've got 5 others. All right. Now, we want to keep G odd. Now, because G is connected to N and H, but H is only connected to G as an odd. So we probably want to keep this one, and this is where we're probably going to end. So that means we want to make these other 2. It'll probably, if I walked, she walks that way once and then does another one, walks along there twice. It's like it's like you're just adding another path, so like edge. So if I added another edge here, like that, this one would become 4 and this one would become 4. And then if I added another edge on that, this would become 4 and this has come 4. So it's like we would have worked along that one twice and this one twice. And if we do that, then we can get a Eulerian trail because they would all be even except for the start and end. So with the question where it says which two vertices, well, we're going to say it's in between N and L, and our other one, which was M and J. Okay, with this question 14, we found that the A and B was done well. Now it's just this question C where it's asking us for the float time, how many activities have a float time of 0. So they're the activities on the critical path. But whenever, hopefully in reading time, I've trying to emphasize, if you see a question on floats, it means you're going to have to draw the boxes on your network. So we would go back to here and we will draw our boxes, earliest and latest starting time boxes, and we'll find the critical path, but we'll also find which ones have a 0 float time. So it's going to help you. You're probably going to need it for other questions or whatever. So remember, we're going to do the two boxes, A and B. Now, I like to have the boxes at the start of the activity so that you can see where, so you've got your options and you can see which one's the longest on the way out and which one's the shortest on the way back. So yeah, it's important to draw them. So if you could just quickly draw them all up at the start. I just find this is, you just don't, if you don't hesitate, you won't waste as much time. Like thinking, I don't want to do this, or, can I just get away with not doing it all? It's just better just start it off and do it all. All right, so 0 is the first time. If we go out via A here, 6 would be C's earliest starting time. And if I get up to F, 6 plus 7 is 13. Now, K, so 13. So 13 could also be here at I, but I've also got a G coming in, so I better go the other way. So if I go along B, D and E is 4. Now D plus 5 4 plus 5 is 9. So here we've got 9 for G and H. Now 9 plus 3 is 12 here, so 13 is the bigger one, so I'll put 13 in. Now if I go via F to K, that would be 13 plus 4 is 17, or 13 plus 6 via I is 19, so that's the bigger one. Then 19 plus 4 would be 23 that way, but I can come in via J, so I'll check that one out. So coming back here, H, 9 plus 7 is 16, and then 6 plus 6 is 22. So 23 is the bigger one. And, if you want, just keep rubbing those out once you've done it so it doesn't get too messy. And then 23 plus 1 is 24. So we finish on 24. Now, if I go backwards, 23. Now, 23 minus 4 is 19. Okay, then if I go 19, if I go back via F, 19 minus 4 is 15. If I go back via I, 19 minus 6 is 13. Now, at this point here, because of that dummy, 13 is the smallest. So 13 minus 7 is 6, and then 6 minus 6 is 0. Okay, so there we go. If I'm at this 13 and I go back via G, so to 13 minus 3 is 10. Now going back to L and I go back via J, 23 minus 6 is 17. and then 17 minus 7 is 10 at H.